Picture a small village nestled somewhere in northern Europe, maybe 10,000 years ago. Dawn breaks over thatched roofs and muddy pathways. Smoke rises from cooking fires. People emerge from their homes wrapped in furs, ready to face another day of survival. And then you see her, a child, maybe 6 or 7 years old, standing at the edge of the settlement. Her hair catches the morning light like copper wire, set aflame. Brilliant, impossible red against the greys and browns of the ancient world. She looks almost otherworldly, like she's carrying fire on her head. Today we see red hair and think Scotland, Ireland, maybe that one kid from your high school. But stop and really think about it for a moment. Why does this trait even exist? Red hair shows up in only 1 to 2% of the global population. That's roughly 140 million people out of 8 billion. It's rare, striking, and for most of human history, it was even more unusual than it is now. This isn't like brown hair or black hair, the colors that helped our ancestors blend into forests and savas. Red hair makes you visible, it makes you stand out. And in the brutal calculus of evolution, standing out is usually a death sentence. So, why are red heads still here? What possible advantage could flame-colored hair have given our ancestors? And more importantly, what can this rare genetic quirk tell us about the people who survived the Ice Age in Europe? About their migrations, their struggles, their incredible journey through some of the harshest conditions humans have ever faced. If you're watching this to fall asleep, perfect. That's exactly why I make these videos. Maybe drop a comment and tell me where you're watching from and what time it is there. I love seeing Tokyo at sunrise, London at lunch, Los Angeles at midnight, all learning the same strange stories about our shared past. Here's the thing that makes red hair so fascinating. It's not just a cosmetic quirk, like preferring one hairstyle over another. It's genetic signature, a molecular fossil that tells us something profound about ancient Europe. Every person with natural red hair carries a specific mutation in their DNA, a change that happened thousands of years ago and has been passed down through countless generations. That mutation has a name, MC1R, and the story of how it spread across Europe is also a story of ice sheets and ancient forests, of population pushed to the edge of survival, of genetic adaptation happening in real time. Red hair almost always comes with other traits: pale skin that burns easily, freckles scattered across faces like tiny maps, higher sensitivity to pain, different responses to anesthesia, a reduced ability to produce vitamin D. These aren't separate characteristics that just happen to occur together. They're all connected, all part of the same genetic package deal, and that package was assembled for a reason. Scientists now believe that red hair, along with the pale skin and freckles that usually accompany it, represents one of evolution's most elegant solutions to a deadly problem. Our ancestors, who moved into northern Europe after the last ice age, faced a crisis. The sun was weak, hidden behind clouds for much of the year. But humans need sunlight to produce vitamin D, which is essential for bone development, immune function, and survival. Dark skin, which had protected our African ancestors from intense UV radiation, now became a liability. It blocked too much of the already scarce sunlight the human body needed to adapt fast. And over thousands of years, it did. Mutations arose that made skin visibly lighter, more translucent, better at capturing every precious photon of northern sunlight. Some of these mutations went further than others. The MC1R mutation didn't just lighten skin, it fundamentally changed how the body produces pigment. The result, the red hair, alabaster skin, and a scattering of freckles that appear when the rare northern sun actually manages to shine through. But this is more than just a story about genetics and survival. It's about identity, about how entire cultures came to associate red hair with magic, with otherness, with gods and heroes and witches. It's about migrations. We're only now beginning to understand about ancient peoples whose DNA we carry, but whose names we'll never know. It's about the precise moment when humans stopped being generic hunter-gatherers and became European, shaped by the land they lived in and the challenges it presented. Tonight, we're going to trace red hair from its mysterious origins through the Celtic heartlands, through Roman chronicles and Viking sagas, all the way to the genetic maps that are revealing where our ancestors walked thousands of years ago. We're going to explore why this rare trait survived where it should have disappeared. And we're going to discover what it really means to carry the mark of ancient Europe written in the very structure of your hair. The flame-haired mystery starts here. Let's find out what it's been trying to tell us all along. Let's talk about what actually causes red hair. Not the folklore, not the myths, but the real biological mechanism that's been creating flame-haired humans for thousands of years. It all comes down to a single gene, MC1R. That's short for melanocortin 1 receptor. And if you've got red hair, this gene is doing something very different in your body than it does in almost everyone else. Here's how it works. Every human produces pigment in their skin and hair through specialized cells called melanocytes. These cells are basically tiny pigment factories, churning out the molecules that give you your color. But they don't just make one kind of pigment, they make two. Eumine-foamelanin. Eumelanin is dark browns and blacks. It's dense, it's protective, and it's really good at absorbing ultraviolet radiation before it can damage your DNA. Think of it as your body's natural sunscreen, built right into every strand of hair and every skin cell. Hinen is different. It's lighter, warmer, reds and yellows and oranges. It doesn't protect you from UV radiation nearly as well. In fact, in some ways, it might actually make UV damage worse, creating free radicals when exposed to sunlight. It's beautiful, but it's not particularly practical if you live somewhere sunny. Most people produce both pigments, but in different ratios. Someone with dark brown hair is producing mostly your melanin with just a little theomelanin mixed in. Someone with blonde hair is producing less of both pigments overall, letting the natural pale color of keratin show through more clearly. But someone with red hair, their melanocytes have basically switched production priorities. They're churning out foamelanin in abundance while producing very little humanin. The result is hair that glows with warm copper, orin or orange tones, instead of the browns and blacks that dominate most human populations. The MC1R gene controls this entire process. It sits on chromosome 16, and its job is to tell those melanocytes factories what to produce. When MC1R is working normally, it responds to signals from your body by producing eumelanin. But when MC1R has certain mutations, it stops responding properly to those signals. The eumelanin production line shuts down or slows to a trickle and famelanin production takes over. There isn't just one mutation that causes this. Scientists have identified over 100 different variants of the MC1R gene, but a handful of specific mutations are particularly good at creating red hair. The most common ones have technical names like R151C, R160W, and D294H2. Each represents a specific change in the gene's DNA sequence, a single-letter alteration in the genetic code that fundamentally changes how your pigment cells behave. What's fascinating is that different mutations create different shades of red. Someone carrying 2 copies of certain variants might have deep auburn hair, rich and dark, with just hints of red in bright sunlight. Someone with different variants might have bright copper hair that practically glows. Still others end up with strawberry blonde, that gorgeous mix of gold and red that seems to shift in different lighting. This spectrum exists because the mutations have different effects on MC1R function. Some completely shut down the receptor, others just reduce its effectiveness. Some combinations of variants will create more humanin than others, leading to darker reds. It's not a simple on-off switch. It's more like a dimmer dial with multiple settings, each creating a slightly different shade. And then there are the freckles. Almost every natural redhead has them scattered across their face and shoulders like constellations. This isn't coincidental. It's a direct consequence of how their melanocytes work. When you have MC1R mutations, your melanocytes don't just produce more familial. Instead of tanning evenly like people with normal FMC1R function, the melanocytes of redheads kick into overdrive in specific spots, creating dense clusters of pigment wherever sun exposure is highest. These clusters of freckles, think of it as your body's desperate attempt at sun protection. It can't produce much humanin for a consistent tan, so instead, it concentrates what little protective pigment it can make into specific areas. The result is skin that remains pale overall, but develops these darker spots wherever UV exposure has been most intense. Some researchers think freckles might actually provide a small amount of protection, creating tiny shields of denser pigment in the most vulnerable areas. Other RS argue they're more of a marker of damage than protection. Signs that your melanocytes are responding to UV radiation they can't adequately defend against. The truth probably lies somewhere in between. Now, here's where genetics gets interesting. Red hair is recessive. Both of your parents have to carry MC1R variants for you to have red hair. If you only inherit one variant, you'll probably have brown or blonde hair, completely unaware that you're carrying the genetic information for red. This is why red hair can seem to appear out of nowhere in families. Two brown-haired parents who both happen to carry MC1R variants can have a red-haired child. The parents might have no idea they were carriers. Their families might not have seen a redhead in generations, but the variants were there hiding, waiting for the right genetic combination. The math is straightforward. If both parents carry one copy of a red hair variant, each child has a 25% chance of inheriting two copies and having red hair, a 50% chance of inheriting one copy and being a carrier like their parents, and a 25% chance of inheriting no variants at all. But biology is messier than simple probability. Some MC1R variants are more penetrant than others, meaning they're more likely to actually produce red hair, even if you only have one copy. Others need to be paired with specific variants to have full effect. There are modifier genes on other chromosomes that can influence the final outcome. Two siblings who both inherit the same MC1R variants might end up with slightly different hair colors because of these other genetic factors. This complexity is part of why red hair is so rare. You need exactly the right combination of genetic variants inherited from both parents with no interfering factors from other genes. The odds of all this lining up are small. Somewhere around 1 to 2% of people worldwide have red hair. In some populations, it's much higher. In Scotland, up to 13% of people are natural redheads. In Ireland, it's around 10%. But globally, redheads are a tiny minority. And yet, that minority has persisted for thousands of years. These MC1R variants didn't just appear randomly. They emerged somewhere, sometime in specific populations facing specific environmental pressures. They survived because despite their disadvantages in sunny climates, they provided some kind of advantage somewhere else. The question is where and when and why evolution would preserve a trait that makes you burn in the sun and produce less protective pigment. To answer that, we need to look backward deep into European prehistory to the moment when these mutations first appeared and began spreading through ancient populations. So now we know what causes red hair. The MC1R gene, sitting on chromosome 16, producing variants that switch off melanin production and leave nothing but phenylanin. But here's the question that keeps geneticists up at night. When did this actually happen? When did the first red-haired human walk the earth? The answer is both simpler and stranger than you might expect. Genetic analysis suggests the MC1R variants responsible for red hair in modern Europeans emerged somewhere between 40,000 and 70,000 years ago. That's a huge window, 30,000 years of uncertainty. But it makes sense when you understand what geneticists are actually looking at. They're not finding ancient red hair preserved in ice or amber. Hair color doesn't fossilize. What they're doing is examining the accumulated mutations in the MC1R gene across different populations, then using molecular clock techniques to estimate when these variants first appeared. Think of it like carbon dating, except instead of measuring radioactive decay, you're measuring the rate at which DNA mutates over generations. If you know roughly how fast mutations accumulate, and you can count how many differences exist between populations, you can work backward to estimate when they diverged. The math puts the origin of European red hair variants somewhere in that 40,000 to 70,000 year window. But here's where it gets weird. Just when researchers thought they had the timeline figured out, they found something nobody expected. Red hair in Neanderthals. Not the same red hair. That's the crucial detail. When geneticists finally managed to extract and sequence Neanderthal DNA from fossils, they found MC1R variants that would have produced red hair and pale skin. But the specific mutations were different from those in modern humans. Different variants in the same gene producing the same result. The Neanderthals had evolved red hair completely independently. Now, pause and consider what this means. Two separate human species evolving on different continents both developed the exact same visible trait through completely different genetic pathways. This is what biologists call convergent evolution. Like how bats and birds both evolved wings, but through entirely different mechanisms. Or how dolphins and sharks both evolved streamlined bodies despite being completely unrelated. Evolution solving the same problem with different tools. But why would both species evolve red hair? What problem was it solving? The answer lies in where and when these mutations appeared. Picture Ice Age Europe, 60,000 years ago. The world is locked in one of the coldest phases of the Pleistocene. Glaciers cover Scandinavia and stretch down across northern Germany. The British Isles are mostly buried under ice sheets a mile thick. What isn't frozen is tundra, endless stretches of grassland and sparse forest where winters last 9 months and summers are brief, cold and cloudy. The sun barely rises during winter. Even in summer, thick clouds and long twilights mean UV radiation is minimal. This is the environment where both Neanderthals and the first modern humans in Europe found themselves. And both face the same biological crisis, vitamin D deficiency. Your body needs ultraviolet radiation to produce vitamin D, not dietary vitamin D, though that helps. But the kind your skin manufactures when UV light hits cholesterol molecules in your cells. Without adequate vitamin D, your bones soften. Children develop rickets. Adults suffer muscle weakness, immune deficiencies, reproductive problems. In severe cases, you die. Dark skin protects against excessive UV radiation. That's why human populations in Africa, where our species evolved, developed high melanin levels, its protective coloration for intense equatorial sun. But in Ice Age Europe, dark skin becomes a liability. It blocks the limited UV radiation available, preventing vitamin D synthesis. Natural selection would favor any genetic variant that lightens skin and lets more UV through. Both Neanderthals and modern humans evolved pale skin independently. And some individuals in both populations took it even further, developing variants that eliminated dark melanin entirely. These were the first redheads, but here's where the story gets complicated. Because modern humans and Neanderthals didn't just coexist in Ice Age Europe, they interbred. The genetic evidence is unambiguous. Every person of European or Asian descent carries 1 to 4% Neanderthal DNA fragment, S inherited from ancient encounters between the two species. So the question becomes, did modern humans inherit red hair variants from Neanderthals through interbreeding, or did we evolve our own variants independently? The answer appears to be both depending on the specific variant. Some red hair alleles in modern populations show no connection to Neanderthal DNA whatsoever. They're purely human innovations, mutations that arose after our ancestors arrived in Europe. Others exist in genomic regions that show signs of Neanderthal ancestry, suggesting they might have been inherited through ancient interbreeding. But here's what's fascinating. The Neanderthal red hair variants that we've identified in fossils don't appear in modern human populations at all. Whatever MISI1R mutations made Neanderthals red-headed, we didn't inherit them. They vanished when Neanderthals went extinct around 40,000 years ago. So, if we didn't get red hair from Neanderthals, why does it exist in the same regions where Neanderthals once lived? Because the environmental pressures were identical. Modern humans arriving in Europe faced the exact same challenges Neanderthals had been dealing with for hundreds of years, thousands of years. Low UV radiation, long dark winters, the constant threat of vitamin D deficiency. Natural selection produced the same solution. Lighten the skin, reduce melanin production, let whatever UV is available penetrate deeper into the tissue. The MC1R gene is particularly prone to mutations that produce this effect. It's a relatively simple genetic switch. Damage it in the right way, and melanin production drops or stops completely. Multiple different mutations can achieve the same result, which is why we see so many different red hair variants in modern populations. Each one represents a separate mutation event, a different individual in whom the MC1R gene broke in a way that happened to be advantageous. This probably happened multiple times in multiple populations as humans spread across northern latitudes. Some variants became common because they provided survival advantages. Others remained rare, persisting in small populations through random chance and genetic drift. A few might have spread through sexual selection if red hair was considered attractive and increased reproductive success, but we're still working with massive uncertainties here. Ancient DNA preserve. Asian is terrible in most environments. We have maybe a few dozen Neanderthal genomes sequenced and only a handful of early modern human genomes from Europe. That's not enough to build a complete picture. Every year, new fossils and new genetic analyses revise our understanding. What we can say, with reasonable confidence, is this. Red hair in modern Europeans is between 40,000 and 70,000 years old, arising during or shortly after the initial modern human expansion into Europe. Some variants may have been present in African populations before the migration, existing at low frequencies where they provided no particular advantage. Once those populations reached high latitudes, those rare variants suddenly became beneficial, spreading rapidly through natural selection. Other variants probably arose as new mutations in European populations, appearing in individuals born with damaged MC1R genes who happened to survive and reproduce successfully. Over thousands of generations, these variants accumulated, creating the diversity of red hair alleles we see today. But here's something researchers are only beginning to understand. Red hair variants aren't evenly distributed across Europe. They're clues. in specific regions, particularly the Celtic fringes of Ireland, Scotland, and Wales. This suggests red hair didn't spread uniformly across the continent. Instead, it arose or became concentrated in particular populations, possibly through founder effects or genetic drift in isolated communities. Some researchers think the high frequency of red hair in Ireland might trace back to a small founding population that arrived after the last ice age, carrying red hair variants that became common simply because the population was small and isolated. Others argue it reflects particularly intense selection pressure in the far northern latitudes where UV radiation is especially limited. We don't know. We have theories, genetic models, statistical analyses, but the actual history of who these people were, where exactly they lived, how they survived, what their lives were like, that's lost. We're reconstructing it from fragments of DNA and statistical inference. What we do know is that by the time written history begins, red hair was already firmly established in northern European populations. Ancient Greek and Roman writers commented on it, describing Celtic and Germanic warriors with ing red hair, which means by 2,000 years ago, the trait was common enough to be noteworthy, distinctive enough to mark certain populations as visibly different from Mediterranean peoples. But the deepest origins remain shadowy. Somewhere in the frozen wastes of Ice Age Europe, in populations struggling to survive in one of the harshest environments humans had ever encountered, a genetic variant appeared that would persist for tens of thousands of years, not because it was beautiful, though it may have been, not because it was sacred, though it would become so in many cultures, but because it solved a simple biological problem: how to synthesize vitamin D when the sun barely shines. That's where red hair began. In the cold and the darkness, as a solution to survival, everything that came after, all the mythology and symbolism and cultural meaning that was added later by humans trying to understand why some of us looked different. But the origin was pure evolutionary pragmatism, a broken gene that happened to work better than the original. Here's the thing about red hair: it shouldn't exist, at least not in the numbers we see it. Most genetic traits that offer no survival advantage EFD randomly through populations, showing up occasionally but never establishing themselves in high frequencies. But red hair isn't randomly distributed. It clusters dramatically. In some regions of Scotland, up to 13% of the population carries the flame-cold trait. In Ireland, it's 10%. Compare that to the global average of less than 2%, and you start to realize something unusual happened in Northern Europe, something that didn't just allow red hair to survive, but actively favored it. The standard explanation is simple, almost too simple. Vitamin D, your body needs it for bone health, immune function, calcium absorption, dozens of critical processes, and the primary way humans get vitamin D is through sunlight exposure. When UV rays hit your skin, they trigger a chemical reaction that produces this essential nutrient. But here's the catch: the more melanin in your skin, the more UV light gets blocked before it can trigger that reaction. Dark skin protects you from too much sun exposure, but it also reduces vitamin D production. In the sun-drenched environments where humans evolved, this wasn't a problem. Africa, the Middle East, Southern Asia, these places have sunlight to spare. Your ancestors could produce all the vitamin D they needed, even with deeply pigmented skin, acting as a natural sunscreen. Then humans moved north, and everything changed. Picture Northern Europe, 12,000 years ago. The glaciers are finally retreating after tens of thousands of years of Ice Age conditions. The landscape is transforming from frozen wasteland to cold, windswept plains. Forests are beginning to spread across territories that had been buried under ice sheets a mile thick. And the humans moving into these territories are facing a problem they've never encountered before: darkness. Not the darkness of night, though the long northern winters certainly provided plenty of that. But the darkness of endless cloud cover, of sun that barely rises above the horizon, even in summer, of forests so dense that sunlight struggles to reach the forest floor, for populations adapted to African or Mediterranean sun levels, this was catastrophic. The archaeological record shows skeletal evidence of vitamin D deficiency in early northern European populations. Rickets, a disease caused by severe vitamin D deficiency, leaves characteristic marks on bones, bowed legs, deformed rib cages, soft, kned skulls. Early farming populations in northern Europe show these markers at alarming rates. They were suffering, their children dying or growing up with permanent disabilities, all because their bodies couldn't produce enough vitamin D in the dim northern light. Natural selection responded the way it always does, ruthlessly. Any genetic variant that helped people survive in low light conditions would be favored. Any mutation that allowed better vitamin D production would spread, and the most obvious solution was to reduce melanin production. Lighter skin absorbs more UV radiation, allowing the same chemical reactions to proceed with less sunlight. Over thousands of years, northern European populations became progressively paler. Darker skin tones were selected against. Lighter ones survived and reproduced, but red hair took this to an extreme. The MC1R variants that produce red hair don't just reduce melanin production. They fundamentally alter how the body produces and distributes pigment. People with red hair typically have the fairest skin of any human population. The kind of skin that burns in minutes, that shows every freckle and sunspot, that seems almost translucent in certain light. This represents the maximum possible reduction in melanin protection. The furthest you can push human pigmentation toward UV absorption. And it worked. At least in certain environments, populations carrying MC1R variants could produce vitamin D in conditions that would leave darker-skinned individuals severely deficient. On overcast days during long winters in dense forests, where only scattered sunlight reached the ground, red-haired individuals had a biochemical advantage. Their children were less likely to develop rickets. Their bones grew stronger. Their immune systems functioned better. In the specific environmental conditions of northwestern Europe, red hair stopped being a quirk and became a survival trait. But if that's the whole story, why didn't red hair spread uniformly across all of northern Europe? Why does it cluster so dramatically in Ireland, Scotland, and parts of Scandinavia, while remaining relatively rare in Poland, Germany, or northern Russia? These areas all have similar latitude, similar cloud cover, similar challenges with vitamin D production. Yet, the genetic distribution is wildly uneven. The answer lies in understanding that evolution isn't just about environmental adaptation. It's about population structure, geographic isolation, and the random chance of which variants happen to be present when populations split apart. The regions with the highest concentrations of red hair are precisely the regions that were most isolated during the crucial period when these populations were establishing themselves. Ireland is an island cut off from the European continent by rising sea levels after the Ice Age. Scotland is a peninsula separated from England by challenging terrain and historically hostile borders. Western Scandinavia consists of isolated fueled communities where each valley maintained relative genetic independence for thousands of years. In these isolated populations, genetic drift could work its magic. If the founding population of Ireland happened to carry a higher frequency of MC1R variants than the European average, those variants would be maintained and amplified over generations. There was no continuous gene flow from outside populations to dilute the trait. The redhead individuals in these isolated communities weren't competing against the entire European gene pool. They were competing only against their neighbor, RS, and in many cases, their relatives. This created what geneticists call a founder effect. A small population establishes itself in a new territory, and whatever genetic variants they happen to carry become the baseline for all future generations. If the founders of Irish populations included several individuals carrying MC1R variants, and those individuals survived and reproduced successfully, their distinctive coloring would become characteristic of the entire population. Not because red hair offered massive survival advantages over brown or blonde, but simply because the founders happened to have it, and isolation prevented alternative variants from diluting it out. But there might be another factor at play. Something more subtle, harder to quantify, but potentially just as important as vitamin D production. Sexual selection. The possibility that ancient Northern Europeans found red hair attractive, or at least distinctive enough to be memorable, which in small populations could provide reproductive advantages. We have hints of this in later historical records. Celtic, Germanic, and Norse sources frequently mention red or golden hair in descriptions of heroes, gods, and legendary figures. Gears. Norse sagas describe Thor as red-bearded. Celtic mythology associates red hair with supernatural power and other worldly origins. Roman accounts of Celtic warriors often emphasize their distinctive coloring, suggesting it was unusual enough to be noteworthy. These cultural attitudes didn't appear from nowhere. They likely reflect much older preferences and associations that have been developing for thousands of years. In small, isolated communities where everyone knows everyone else, being visually distinctive could be advantageous. Red hair is memorable. It stands out. In societies where reputation and social networks determine survival, being the person everyone remembered might help you form alliances, secure support, establish yourself as a skilled craftsperson or warrior. If redhead individuals were even slightly more successful at forming social connections, they would have more children, and their distinctive coloring would spread, not through better vitamin D production, but through better social outcomes. There's also something fascinating happening at the biochemical level that we're only beginning to understand. The MC1R gene doesn't just control pigmentation, it's involved in multiple physiological pathways. Recent researchers discover that people with MC1R variants process pain differently than those without them. They appear to have altered pain sensitivity, requiring different doses of anesthesia for the same procedures. They may respond differently to certain medications. They might even have different immune system responses. This suggests that red hair isn't just about vitamin D. It's a marker for a whole suite of biochemical differences, most of which we don't yet fully understand. Some of these differences might have been advantageous in specific environments or circumstances. Perhaps altered immune function helped resist particular diseases that were common in cold, damp, northern climates. Perhaps different pain processing helped individuals endure the extreme cold and physical hardships of Ice Age survival. We simply don't know yet. The research is ongoing, revealing complexities we hadn't imagined. What we do know is that red hair represents an extreme adaptation, a pushing of human pigmentation to its limits in response to environmental pressures. The people who carried these traits weren't just surviving in Northern Europe. They were thriving, at least in certain pockets, creating societies, raising families, developing the cultural traditions that would eventually become Celtic and Germanic civilization. But they were also paying a price. That extraordinarily fair skin that absorbed UV so efficiently also left them vulnerable. Skin cancer rates among red-haired populations are significantly higher than other groups. Sun damage accumulates faster. The same trait that helped their ancestors survive northern winters makes their descendants vulnerable in summer sun, or if they migrate to sunnier climates. This is the fundamental nature of evolutionary trade-offs. There's no perfect adaptation, no genetic variant that provides only benefits with no costs. Red hair helped people survive in specific environmental conditions by solving the vitamin D problem, but it created vulnerability to sun damage. It increased melanoma risk. It made carriers more sensitive to temperature extremes. Evolution doesn't care about these downsides as long as the overall fitness benefit outweighs the costs. And for thousands of years in isolated northern European populations, it did. The flame-haired populations that emerge from this selective pressure weren't just genetically unique. They were geographically concentrated in exactly the regions where their traits provided maximum advantage. The cloudy, cool climates of Ireland and Scotland, the long winter landscapes of Scandinavia, the forest-covered hills where sunlight was scarce even in summer. These weren't accidents of history. They were the environments where red hair transformed from liability to asset, where the very traits that would have been dangerous in Africa or the Mediterranean became the key to survival in the dim northern light. And they were about to spread their distinctive appearance across a much wider world. Walk through Dublin today, and you'll see them everywhere. People with hair the color of autumn leaves, copper wire, rust on ancient iron. Ireland holds the world record for red hair frequency. 10 to 15% of the population. That's not a small genetic quirk. That's a defining characteristic of an entire nation. Scotland comes in second with 6 to 13%, depending on the region. The Highlands show even higher concentrations in some areas. Wales follows at 10 to 15% in certain communities. These aren't just the highest concentrations in the world, LD. They're outliers so extreme they demand explanation. But here's what makes this distribution really fascinating. It's not evenly spread across the British Isles. It concentrates in specific regions, like someone deliberately painted red hair onto the map in certain places and ignored others. The western coasts of Ireland and Scotland show the highest frequencies. The wind-swept Atlantic shores where rain falls 200 days a year and the sun is a rare visitor. Move inland, move east toward England, and the frequencies drop, not dramatically, but measurably. This isn't random. This is a pattern written in both geography and history. So, where did all these red-headed Celts come from? The popular story goes like this. The Celts, those iron-working warrior poet cultures of ancient Europe, swept across the continent around 1200 BCE, eventually reaching the British Isles and bringing their genes with them. Red hair in this version is the Celtic marker, the genetic signature of these ancient tribes. But the genetics tell a more complicated story. The Celts did arrive in Britain and Ireland probably in waves between 1500 and 500 BCE. They brought their languages, their metalwork technologies, their art styles, but they weren't arriving in an empty land. They were arriving in a place that had been continuously inhabited for thousands of years. The British Isles had supported human populations since the end of the last ice age around 12,000 years ago. Mesolithic hunter-gatherers crossed over from continental Europe when Britain was still connected by land bridges. They hunted deer in ancient forests, fished in pristine rivers, gathered shellfish along coasts that would later be drowned by rising seas. Then around 6,000 years ago, the first farmers arrived, Neolithic peoples who brought agriculture, pottery, and the knowledge to build those massive stone monuments that still dot the landscape. New Gronge in Ireland, Skara in Scotland. These weren't built by Celts. They were already ancient when Celtic languages first echoed across these hills. So when the Celts arrived, they encountered populations that had been living in the British Isles for millennia, populations that had already adapted to the local climate. And here's the critical question. Did those pre-Celtic populations already carry the MC1R variants that produce red hair? The answer is probably yes. An Shunt DNA, extracted from Neolithic burial sites in Ireland, shows the presence of MISI1R variants. Not in everyone, but frequently enough to suggest the trait was already circulating in the population thousands of years before anyone spoke a Celtic language. A tomb at Ballinahati in Northern Ireland yielded DNA from a woman who lived around 5,200 years ago. Analysis of her genome shows she likely had dark hair and dark eyes, but she carried variants associated with lighter pigmentation. Not quite the full red head package, but genetic material that could contribute to it in later generations. Scottish sites tell similar stories. Ancient remains from the Orkney Islands, those wind-swept specks of land north of the Scottish mainland, show a population that was genetically distinct from later arrivals. But they too carried some variants associated with lighter pigmentation. What this means is that red hair in the British Isles isn't simply a Celtic import. It's the result of deep genetic history in these islands, layer upon layer of populations mixing and adapting. The Mesolithic hunters, the Neolithic farmers, the Bronze Age warriors, and yes, eventually the Celts all contributed to the generation. Etic pool. But the Celts weren't the end of the story either. They established themselves as the dominant culture across much of the British Isles, their languages eventually becoming Irish Gaelic, Scottish Gaelic, and Welsh. They farmed the fertile valleys, built hill forts on strategic heights, and created the artistic traditions that still influence Celtic regions today. And in their populations, red hair thrived. The combination of existing MC1R variants, plus new genetic material brought by Celtic migrations, all filtered through the environmental pressures of these northern latitudes, created the perfect conditions for red hair to reach frequencies seen nowhere else on Earth. The climate played its role too. Ireland and Scotland sit at latitudes where sunlight is precious. Winter days when the sun barely rises above the horizon. Summer days when it never quite sets, but its rays come in at such low angles that vitamin D production is a constant challenge. The landscape doesn't help. These are cloud factories. Atlantic weather systems roll in off the ocean, dump their moisture on the western coasts, and keep the sun hidden for days or weeks at a time. It's beautiful if you like. Key dramatic grey skies and ever-changing light. It's brutal if your body needs sunlight to produce vitamin D. Under these conditions, lighter skin isn't just an advantage, it's a necessity. And red hair comes as part of that package, linked through the same genetic pathways that regulate pigmentation overall. But the Celtic heartland extends beyond just the British Isles. Look at the Atlantic coast of Europe and you'll see something remarkable. A string of populations with elevated red hair frequencies stretching from Scotland down to Portugal. Brittany and northwestern France shows 4 to 6% red hair, higher than the French average. Brittany also speaks a Celtic language, or did until recently. Bratton closely related to Welsh and Cornish. These are descendants of Celtic populations who migrated from Britain in the early medieval period, bringing their genes and their language across the Channel. But Galicia in northwestern Spain also shows elevated frequencies, and Galicia has a complicated history. Celtic tribes definitely settled there, giving the region its name, the Galli, Roman writers called them. But genetic analysis shows the Galician population is a complex mix, Celtic migrant, layered over earlier Iberian populations, all adapted to the rainy Atlantic coast. Even coastal Portugal shows slightly elevated red hair frequencies compared to the Mediterranean interior. This entire Atlantic fringe from Scotland to Portugal shares something: a maritime climate, cool and wet, populations with ancient connections, trade routes, and migrations stretching back millennia, and a genetic tendency toward lighter pigmentation, including red hair. Some researchers call this the Atlantic megalithic culture. Not a single people, but a network of coastal populations connected by sea travel. They built similar stone monuments, shared certain cultural practices, and traded goods across vast distances. They were the Bronze Age mariners, the prehistoric sailors who linked these coasts long before anyone thought of them as separate nations. And in all these populations, red hair persisted, not as common as in Ireland or Scotland, but present enough to be notable, a genetic thread connecting these western lands. Then came the Vikings. Starting in the late 8th century, Norse raiders began appearing on the coasts of Britain and Ireland. What started as hit-and-run attacks eventually became conquest and settlement. The Vikings established kingdoms in Ireland, conquered much of northern England, settled extensively in Scotland and the islands, and yes, the Norse brought their own genes. Genetic analysis of modern Irish and Scottish populations shows clear Scandinavian ancestry. In some regions, particularly the northern and westerns, Norse genetic contribution can reach 20 to 30% of the total. But did the Vikings bring red hair or dilute it? The answer is both. Scandinavia has lower red hair frequencies than Ireland or Scotland, typically 1 to 2%. So, Norse genetic admixture would tend to reduce red hair frequencies in the areas they settled. But Scandinavian populations also carry MC1R variants just at lower frequencies. And those variants, when mixed with the already high frequencies in Celtic populations, could still produce redhead offspring. More importantly, the Vikings didn't replace the local populations. They conquered, they settled, they intermarried, but the bulk of the genetic ancestry in Ireland and Scotland remained from the earlier inhabitants. The Norse added a layer, one more contribution to an already complex genetic history. By the medieval period, the genetic landscape of the Celtic heartland was essentially complete. Mesolithic hunter-gatherers, Neolithic farmers, Bronze Age peoples, Celtic migrants, and Norse settlers all mixed together, all living under the same cloudy Atlantic skies that favored lighter pigmentation. The result is the pattern we see today: Ireland and Scotland as the undisputed global centers of red hair, Wales, Brittany, and other Atlantic populations showing elevated but lower frequencies and a genetic legacy that stretches back not just centuries but millennia. Every red-haired person in Dublin or Edinburgh carries in their DNA a story of ancient migrations, environmental adaptation, and the accumulated genetic history of dozens of ancestral populations. They are, in a very real sense, living links to the deep past of northwestern Europe. The landscape itself seems built for red hair: green hills rolling down to grey seas, stone walls weathered by centuries of Atlantic rain, light that shifts constantly, turning russet hair to copper, then to bronze, then to flame, depending on the angle and intensity. It's no wonder red hair became woven into the cultural identity of these regions. When 10 to 15% of your population has flame-cold hair, it stops being an oddity and becomes part of the national character. It shows up in poetry, in folklore, in the basic visual identity of what it means to be Irish or Scottish. But it's not about nationalism or cultural pride. It's about deep time, about environmental pressures operating over thousands of generations, about populations adapting to the specific challenges of specific places. The Celtic heartland isn't just where red hair happens to be most common. It's where the genetic, environmental, and historical factors all aligned to create the perfect conditions for this rare trait to flourish. And flourish it did. The Romans couldn't stop talking about them. When Julius Caesar's legions pushed into Gaul and Germania, the soldiers returned with stories that seemed almost mythological. Tribes of warriors with hair the color of fire. Not just a few individuals here and there, but entire populations where red and hair was common enough to be remarkable. The Roman historian, Tacitus, wrote detailed accounts of the Germanic tribes, noting specifically their fierce blue eyes and reddish hair. He wasn't making this up for dramatic effect. Archaeology Archaeological evidence from Germanic burial sites confirms what the literary sources tell us. These were populations where red hair variants were genuinely prevalent, possibly even more common than in the same regions today. But the Germans weren't alone. Travel east, and you'd encounter the Thracians, the fierce warriors who occupied what's now Bulgaria and parts of Greece and Turkey. Greek pottery and sculpture depicted them with unmistakably reddish hair. The Greeks seem fascinated by this feature, noting it repeatedly in their descriptions of Thracian captives and mercenaries. Move west instead, and you'd find the Gauls, the Celtic peoples of modern France and Belgium. Roman accounts describe Gaulish warriors who lime-wash their hair to make it even more spectacularly red and spiky. This tells us something important. They weren't trying to cover up their natural hair color. They were enhancing it, taking what was already red or making it even more dramatic. You don't enhance a feature unless it's already present in your population at notable frequencies. These weren't isolated observations by confused travelers. These were systematic accounts by people who had spent years living among, trading, with, and fighting against these populations. The Romans knew what they were looking at. Red hair was a defining characteristic of the northern peoples they encountered as they expanded their empire beyond the Mediterranean. But here's where the story gets really interesting. Red hair wasn't confined to Europe. In the 1990s, archaeologists working in the Tarim Basin of western China made a discovery that would challenge everything we thought we knew about ancient human migrations. They found mummies, not Egyptian-style mummies, but bodies naturally preserved by the dry desert conditions. And these bodies looked nothing like what anyone expected to find in China. They had European features, tall stature, high-bridged noses, deep-set eyes, and most remarkably, many of them had red or orange hair, perfectly preserved after thousands of years in the desert, still showing the distinctive reddish pigmentation that marks MC1R variants. The Trim mummies date from around 2000 BCE to 200 CE. That's roughly contemporary with the height of Celtic Europe. The peak of red hair frequency in places like Ireland and Scotland. But these people weren't in Ireland or Scotland. They were in Western Kai, thousands of miles from any known European population. Who were they? The linguistic evidence provides some clues. The region where the mummies were found was once home to a people called the Tocharians. We know about them because they left behind written texts in an Indo-European language, a language family that includes most European tongues, but was completely unexpected this far east in Asia. The Tocharians were migrants. Their ancestors had traveled east from somewhere in the European steppes, probably during the Great Bronze Age migrations that reshaped much of Eurasia, and they brought their genes with them, including the variants that produced red hair. This tells us something profound about ancient population movements. Red hair wasn't just spreading through Europe, it was being carried along the ancient migration routes that connected Europe and Asia. The same routes that brought horses, chariots, and Indo-European languages eastward were also dispersing the genetic variants that produced distinctive European features. But the Tarim Basin wasn't the only place where European genes showed up in unexpected locations. Look at the Scythians, the nomadic peoples who dominated the Eurasian steppes for over 1,000 years. The Scythians left behind elaborate burials, frozen tombs in the Alai Mountains, where bodies and grave goods were preserved in permafrost. Modern analysis of these remains shows remarkable diversity. Some individuals had clearly East Asian features and dark hair. Others looked unmistakably European with lighter hair colors, including auburn and red. This wasn't a mistake. The Scythians were a confederation of many different peoples, united by lifestyle and culture rather than genetics. As they moved across the steppes, they intermarried with local populations, creating a genetic mosaic that blended European and Asian ancestry. And they carried red hair genes with them. Genetic analysis of ancient Scian DNA shows MC1R variants present in multiple individuals from different time periods and locations. The steppes were acting as a genetic highway, moving genes back and forth between Europe and Asia over thousands of years. Some of those genes ended up very far from home. Indeed, modern populations in Central Asia, groups that look predominantly Asian, still carry traces of ancient European ancestry. And occasionally, that ancestry produces red hair in populations where you'd least expect it. It's rare, but it happens. A genetic echo of migrations that occurred thousands of years ago. But perhaps the most intriguing ancient red hair mystery comes from a place that seems completely wrong for it: Egypt. Ramses II, arguably Egypt's greatest pharaoh, had reddish hair. We know this because his mummy still exists, and the hair is clearly reddish-orange in color. But there's a problem. Egypt is not a place where you'd expect natural red hair. The climate is wrong. The ancestors, RAL population is wrong. Everything about Egypt suggests this shouldn't be possible. So, what's going on? There are three main theories, and nobody knows for certain which is correct. Theory 1, it wasn't natural. The ancient Egyptians used henna extensively, both on living people and on the deceased, as part of mummification rituals. Ramesses II's hair might have been dyed either during his life or after his death. This is plausible. We know the Egyptians did this, but it doesn't fully explain why his hair shows reddish pigmentation in a pattern consistent with natural red hair rather than uniform dye coverage. Theory 2, it's a product of mummification. The chemicals and processes used to preserve the body might have altered the hair color over thousands of years, turning naturally dark hair reddish. This happens with some preserved remains, but experts who have examined Ramses II's hair closely say the pigmentation pattern doesn't look like chemical alteration. It looks like natural red hair that has faded and oxidized with age. Theory 3, it actually was natural. This is the most intriguing possibility. Ancient Egypt wasn't genetically isolated. The Nile Delta had extensive trade connections with the Mediterranean world. Greeks, Canaanites, Libyans, all sorts of populations mixed with native Egyptians over millennia. The Egyptian royal family, in particular, frequently married foreign princesses as part of diplomatic alliances. It's entirely possible that somewhere in Ramses II's ancestry, someone carried MC1R variants, maybe a Greek grandmother, maybe a Libyan great-grandfather, maybe an ancient mixture that predated historical records entirely. One or two red hair alleles in an otherwise dark-haired population could produce orange or reddish-brown hair, exactly what we see in Ramses II's remains. We may never know for certain, but the fact that we're even asking the question tells us something important. Red hair could show up in unexpected places in the ancient world. It wasn't confined to one region or one people. It moved with human populations as they migrated, traded, and intermarried across vast distances. The ancient world was far more connected than we often imagine. Trade routes linked Britain to Rome, Rome to Egypt, Egypt to Persia, Persia to India, India to China. And along those routes, genes flowed, not in massive waves, but in small increments. Ents, a trader who settled far from home, a captured slave who bore children in a foreign land, a princess married off to secure an alliance between distant kingdoms. Each of these movements carried genes with them, including occasionally the variants that produced red hair. So, you'd get isolated instances of red hair showing up in populations where it was otherwise vanishingly rare. A Persian text mentions red-haired people among certain mountain tribes. Chinese sources describe Western barbarians with strange hair colors. Indian legends speak of foreign warriors with heroic flames. These weren't fantasies. They were observations of real genetic variation, traces of ancient migrations, and mixtures that we can now confirm through DNA analysis. The picture that emerges is of red hair as a kind of genetic marker. Not a perfect one because the same variants evolved independently in different populations occasionally, but generally red hair, in ancient sources, tells us about population movements and connections that might otherwise be invisible in the archaeological record. When Romans described red-haired Gauls, they were documenting the Celtic expansion across Western Europe. When Greeks wrote about red-haired Thrians, they were noting the genetic legacy of ancient migrations from the steppes. When Chinese sources described red-haired foreigners, they were observing the eastern edge of Indo-European expansion. And when we find red-haired mummies in the Tar Basin, thousands of miles from any modern red-haired population center, we're seeing direct physical evidence of ancient peoples who traveled farther than we ever imagined, carrying their distinctive genetics into regions where those traits would eventually vanish through admixture with local populations. But in a few places, red hair didn't vanish. It flourished. It became concentrated at frequencies far higher than anywhere else on Earth. The question is why? What made certain regions of Northern Europe into red hair epicenters when the gene variants were scattered so widely across the ancient world? The answer lies in the intersection of climate, culture, and pure chance. And it's more complex than you might think. Close your eyes for a moment and imagine this. You're sitting by a fire somewhere in ancient Europe. The flames are low. The air smells like smoke and damp earth. And around you, people are sparing. Not about the stars, not about the hunt, but about someone in the village. Someone whose hair in the firelight glows the same color as the coals. For most of human history, that would have meant one thing. This person was not just different, they were meaningful. Because before we had genetics, we had stories. Red hair is rare, unpredictable, and impossible to ignore. In small prehistory communities, anything rare and striking tends to get pulled into the orbit of myth. People look at it, they point to it, and they start asking questions. Why them? What does it mean? Is it a blessing or a warning? Across the ancient world, answers to that question split in two directions. On one side, red hair meant fire, passion, divine strength, supernatural power. On the other, it meant danger, betrayal, chaos, witchcraft, and often the same culture could hold both ideas at once. Let's start in the north, where winter nights are long, and fire really does mean life or death. In Norse Germanic tradition, the gods were not abstract ideas. They were imagined as very physical beings. They ate, they fought, they bled. They had scars and tempers and very specific looks. When people described T, he thunder god, the one who hurled lightning bolts and crashed across the sky in storms, they didn't picture a quiet, pale figure with delicate features. They imagined someone who looked like the storm itself, loud, intense, bright. Thor, in later medieval sources, is often described as having a red beard, not golden, not brown, red, a face framed by something that looked like fire. Now, we don't have a neat, unbroken record from the Bronze Age that says Thor was definitely red-haired. Oral traditions shift, merge, and evolve over centuries. But the association of thunder gods and storm gods with red hair and red beards shows up again and again in Northern European folklore. Even into the early modern period, you find rural stories about red-bearded smiths, red-haired giants, red-headed spirits linked with lightning and metal and sudden dangerous energy. Why a red beard? In a world lit mostly by fire, red hair in torchlight doesn't just look colorful. It looks like flame. It glows orange, copper, almost molten like iron just pulled from the forge. If you're trying to imagine a god of thunder and war, a protector who smashes frost giants and wrestles monsters, a fiery beard is a perfect visual shorthand. It also fits with how northern peoples thought about power. Strength wasn't calm and smooth. It was rough, hot, unpredictable. Storms, volcanic eruptions, roaring bonfires, all of that got bundled together in the imagination. Red hair slotted into that symbolic system, very naturally. It was visual evidence that a person carried a bit of that cosmic heat. So, in some Normannic contexts, the red-haired or red-bearded figure could be a symbol of protection, vitality, and divine force. The kind of person you'd want on your side in a raid or in a blizzard. But the same palette of associations, fire, blood, intensity, could be flipped and used for something darker. To see that side, we have to move south to a river valley where the color red meant something very specific. Ancient Egypt. In the Egyptian worldview, color wasn't just descriptive. It was loaded with meaning. Black was fertility and rich soil. Green was life and growth. And red was dangerous. The desert surrounding the Nile was called the Red Land. It was harsh, dry, full of hazards. And the god associated with that realm with chaos, storms and violent disruption was Set. Set was not a gentle film. Gear. He murdered his brother Osiris, fought with Horus, and represented forces that constantly threatened to pull the world out of balance. Over time, especially in later periods, he became a sort of template for foreign invaders, hostile deserts, and anything that felt like cosmic disorder. The Egyptians did not talk about redheads the way modern Europeans do, but they did view red as set color. Red animals, red minerals, red pigments, all could be linked to him. Some ancient texts and later interpretations suggest that people with especially reddish hair or with a ruddy complexion might be symbolically associated with Set energy, dangerous, chaotic, uncontrolled. In certain rituals, red-haired animals were sacrificed to Set or destroyed as stand-ins for him. There are later Greek and Roman accounts claiming that red-headed humans were at times sacrificed in Egypt as embodiment of Set. Though historians debate how literal or widespread that really was, it's hard to know where reality ends and foreign exaggeration begins. But what matters for our story is the pattern. Red could mean other. Red could mean enemy. Red could mean the god of chaos is nearby. So already in two very different, rent cultures you see the same color evoking two opposite meanings. Divine warrior on one side, cosmic traitor on the other. Ancient Greece, sitting between northern Europe and Egypt, gives us something more complicated. Greek art and literature talk a lot about appearance. They describe blonde hair, dark hair, curly hair. They notice details, and sometimes they hint at reddish hair that doesn't quite fit the usual categories. The Greeks tended to idealize what they saw as the beautiful golden mean. Not too dark, not too pale. Golden or chestnut hair was praised in poetry. Too black could be foreign. Too pale could be strange. And strongly red hair sometimes sat just outside the ideal. Certain Greek writers associated very red or fiery hair with Thryans and other northern peoples' tribes they saw as wild, warlike, and less civilized. You can almost hear the undertone. Those barbarians up there with their loud clothes and bright hair, they're not like us. At the same time, some heroes and semi-divine figures are described with hair that could be interpreted as coppery or reddish gold. Translators will often render it as flame-cold, tawny, or fiery. It's hard to map those descriptions closely onto modern categories like red-head or strawberry blonde, but the symbolism is clear. Fire-cold hair was dramatic. It suggested passion, intensity, maybe a dangerous charm. This double vision, admiring the beauty of unusual hair while also coding it as foreign or excessive, tells us something important. Ancient reactions to red hair weren't uniform. They depended on context, class, and storytelling needs. If you wanted a seductive, disruptive figure, someone who charms and destroys, you might give them hair like a flame. If you wanted a barbarian enemy at the edge of the map, you might give them hair so bright it looked unnatural. Either way, the hair color became a storytelling tool. A quick visual way to signal this person is not ordinary. Over centuries, as Mediterranean religions mixed with northern and eastern influences, that toolbox of symbols kept expanding. By the time medieval Europe emerged, the cultural baggage attached to red hair had grown very heavy. Then a single story retold thousands of times locked part of that baggage in place. The story of Judas. In the early centuries of Christianity, the Bible didn't say what Judas Iscariot looked like, his hair color, ARE, his height, his build. None of that is specified in the text. The artist had a problem to solve. If you're painting or carving the Last Supper, how do you make it instantly obvious which one is the betrayer? You can't put a modern movie caption over his head. You can't make him literally glow with the word villain. You need a visual shorthand the audience understands. So, in many parts of medieval Europe, Judas began to be painted with red hair. Not always, not everywhere, but often enough that it became a pattern. In church fresco, altarpieces, illuminated manuscripts, the man who sells out Christ for silver is marked with hair and beard shades that stand out sharply from the calmer browns and blacks of the apostles around him. This wasn't an accident. By that time, red hair already carried undertones of excess and suspicion in European folklore. It could be associated with hot tempers, lust, deceit. In some regions, it was linked to neighboring others, Vikings, steppe nomads, or local minorities who looked different from the majority population. Tying Judas to that palette visually reinforced the message. Here is someone untrustworthy, someone touched by a dangerous difference. As centuries passed, that artistic choice leaked out of churches and into everyday stereotypes. Red hair, Judas' heart, some said a casual visual code in paintings had become a cultural script, and medieval Europe didn't stop there. Between the late Middle Ages and the early modern period, anxieties about magic, heresy, and the supernatural reached fever pitch. The witch hunts, the obsession with demonic pacts, the fear of anything that didn't fit neatly into official doctrine. All of that needed targets. Once again, visible difference became convenient. Red hair, already tied to Judas' set chaos, foreignness, and wildness in various traditions, slid easily into the role of a warning sign. Not in every village, not in every trial record, but often enough to leave a mark on folklore. Stories began to describe witches with wild red hair streaming around their faces as they flew through the night. Vampires and revenants in some Eastern European tales were said to have reddish hair or beards, as if their bodies still held a trace of the blood they drank. People whispered that children born with fiery hair were more likely to be temperamental, lustful, or prone to cursing. It's important to underline what's actually happening here. No one ran a statistical study. No one compared populations. These were not data-driven claims. They were projections, cultural fears, religious anxieties, xenophobic suspicions. All of that needed a visible hook, a way to turn inner unease into outer labels. Red hair provided an easy hook. Imagine living in a small medieval town. Most people have similar hair shades, similar skin tones. Then a baby is born with hair that looks like copper in the sun. Or a stranger arrives whose beard looks almost orange. In a time without genetics, without modern medicine, without scientific frameworks, how do you explain that? You don't. You symbolize it. You say that the person is touched by fire, or by the devil, or by some foreign god. You connect them in your mind to every story you've heard, where hair like that is linked to danger or power. You let the myth do the thinking for you. And yet, even in the middle of all that suspicion, red hair never belonged only to the dark side of the ledger. In some folk tales, red-headed children are destined for greatness. In others, red-haired warriors are the bravest in battle. In still others, beautiful women, the copper hair are irresistible, blessed with a kind of enchanted charm that kings and knights can't ignore. The same trait that made people nervous also made them fascinated. When you step back and look at the pattern across cultures, from red-bearded thunder gods to Set in the Redland to fiery Greek strangers to Judas in stained glass to witches and vampires, the conclusion is not that red-haired people were born under a curse. The conclusion is that human societies are very good at pouring their fears and fantasies into whatever stands out. Red hair happens to stand out. In biological terms, it's just one outcome of variation in the MC1R gene and related pathways. A different balance of pigmentation, a different way of handling sunlight, a different set of alleles passed down through time. But for ancient and medieval observers who didn't know about genes, it looked like a message from somewhere else. So they wrote stories to explain the message. Some stories made red heads divine. Some made them monstrous. Many did both at once. And this is where the myths become more revealing than they seem. When a culture treats red hair as a sign of passion, that tells you it's struggling with desire and self-control. When it treats it as a mark of chaos, that tells you it's anxious about outsiders, storms, deserts, invasions. When it turns red hair into the signature of a traitor like Judas, that tells you it wants an easy way to spot betrayal. Even though real betrayal never announces itself so clearly, in the end, the myths surrounding red hair aren't really about the people who had it. They're mirrors held up to the societies that told them, mirrors showing fear of the unknown, fascination with intensity, and a constant human habit. Taking something as simple as a hair color and turning it into a story about gods, demons, loyalty, and danger. And while the old superstitions have faded, their echoes are still with us in jokes, in clichés, in half-remembered sayings about fiery tempers and ginger souls. Most people don't actually believe in redhead witches or set-mark strangers anymore. But the storytelling momentum built over thousands of years doesn't vanish overnight. It lingers quietly in the background. And as we move from myth back into genetics, you'll see something almost ironic. The same trait that was once blamed on demons and desert gods turns out to be a perfectly natural adaptation. A small, elegant adjustment that helped certain ancestors survive in places where the sun is weak, the winters are long, and any extra bit of vitamin D could mean the difference between life and death. The fire in the hair was never a curse. It was evolution's quiet, efficient answer to a cold, grey world. Picture Europe at the end of the last ice age. There are no castles yet, no Celtic tribes, no Vikings, no Romans, just forests, rivers and small bands of hunter-gatherers following herds and seasons. If you could zoom out and see the continent from above, you wouldn't see nations or borders. You'd see tiny human sparks scattered thinly from Iberia to the Baltic, from the Atlantic coast to the edges of the steppe. Those first people after the ice were the Mesolithic hunter-gatherers, dark-haired, dark-eyed, with relatively darker skin compared to later Europeans, adapted to a world where sunlight was still weak. But life was lived largely outdoors. Their genes form the oldest layer of Europe's genetic map, the background canvas on which everything else would later be painted. For thousands of years, they were almost alone in this landscape, small groups, moving with seasons, sometimes meeting, sometimes fighting, often trading mates and ideas. Just like the meta-populations after the ancient bottleneck, these bands rose and fell. Some lines ended quietly in forgotten valleys. Others left descendants who would one day be buried under Roman roads and medieval cathedrals. In these early hunter-gatherers, we already see the seeds of Europe's future hair colors, not bright copper yet, not in the way we think of red head today, but genetic variation in the MC1R gene and related pigmentation genes was there, quietly ticking in the background. Some alleles made skin slightly lighter. Some affected how melanin was balanced between darker eumelanin and lighter pheomelanin. In a world where vitamin D from sunlight mattered, but sunburn was still a danger, nature was experimenting. Then, around 9,000 to 7,500 years ago, a new wave began to roll in from the southeast. Farmers, they came from Anatolia and the Near East, bringing wheat, barley, sheep, goats, and new genes. They didn't move as one huge migration, but as many small ones, village by village, family by family, clearing forests, planting fields, and slowly pushing their way up the Danube back, as in along the Mediterranean coasts, into Central Europe. Genetically, these Neolithic farmers were different from the Mesolithic hunter-gatherers. They carried their own set of pigmentation variants. Many of them had relatively lighter skin than the original Europeans, adapted to farming lifestyles, where people spent more time indoors, where diet changed, and where vitamin D production in the skin became even more crucial. Some of their genes lightened eyes and hair, as well, not necessarily blazing red, but laying down more of the palette. Blondish browns, lighter browns, more variation. If you could have watched the continent over a few thousand years, it would have looked like two colors of ink mixing on wet paper. Hunter-gatherers retreating to forests and coasts, sometimes intermarrying with the farmers, sometimes resisting, sometimes vanishing. Farmers spreading, settling, building megaliths and causeway enclosures. With every child born between a farmer and a forager, the genetic deck was reshuffled. New combinations of pigmentation variants appeared, some slightly better adapted to northern skies, some not. Nature kept choosing. For a while, it might have seemed like the saint. Ori was finished. Farmers had remade the landscape. Grain fields replaced wild meadows. Population numbers surged. But then a third wave began to move. This time from the east, steppe herders. Around 5,000 to 4,500 years ago, people from the Pontic Caspian steppe, vast grasslands north of the Black and Caspian seas, began pushing into Europe. They brought horses, wheeled vehicles, new social structures, and most importantly for our story, new genes. Many geneticists associate this wave with the Yamna and related cultures. Mobile, pastoral, often warlike. They didn't just slip quietly into Europe, they crashed into it. In DNA, from this steppe ancestry, we see a different balance of pigmentation variants again. Variants that favored lighter eyes and lighter hair show up at higher frequencies. Some of the MC1R mutations linked to red hair later in northwestern Europe seem to have been present in these populations as rare alleles, mixing with existing European diversity. So now Europe had three major ancestral threads woven together: Mesolithic hunter-gatherers, Neolithic farmers, and Bronze Age steppe peoples. Each with their own portfolio of pigmentation genes, each contributing different shade, S, to the human spectrum. The question is, why did Western and Northern Europe, especially places like Ireland and Scotland, end up with so much of one very specific color, red, while Eastern and Southern Europe did not? Part of the answer lies not in grand invasions, but in the quiet mathematics of small populations. Imagine Ireland and Britain during the late Neolithic and Bronze Age, islands at the far edge of the continent, not empty, but sparsely populated. New arrivals from the continent arrive in waves. The first farmers then steppe influence groups, but each wave is small. Dozens, hundreds, maybe a few thousand people at a time. Once they settle, the sea becomes both a barrier and a filter. Jean flow continues with the mainland, but at a trickle, if by chance some of those early island populations carried particular MSI1R variants that increased the likelihood of red hair. And if those families happen to expand, their genes could rise to high frequency, not because they were better, but simply because they were there first in the right place at the right time. This is the founder effect. You start a new population with a small sample of the original genetic diversity. Whatever random variants the group carries become the baseline for everyone who comes after. If a few of those founders had red hair-associated MSI1R variants, those alleles could become common throughout the island, even if they were rare on the continent. Then comes genetic drift. In small or relatively isolated populations, chance events matter a lot. Maybe a family with several red-haired children has more surviving offspring during a period of famine. Maybe a local clan with a high frequency of MSI1R variants holds power for a few centuries, having more children, more grandchildren. Over time, random fluctuations can push certain alleles to high frequencies, especially when there's no strong selection against them. Northern latitudes with weak sunlight actually provide a mild selective advantage to lighter skin and often indirectly to hair and eye colors that come bundled with lighter pigmentation. That doesn't favor red hair in a direct, targeted way, but it keeps the door open. It lets those variants drift upwards instead of being pushed out. Meanwhile, in southern Europe, the story is different. The Neolithic farmers leaving the warm climates of the Near East brought many light-skin variants, but the intensity of Mediterranean sun placed limits on how far depigmentation could go without cost. Darker hair and eyes offered protection. Vitamin D could be obtained more easily from sunlight and from diets that included more fish and olive oil. MSI1 are mutants that produced extreme red hair, and very low humanin may have been less favored or simply never reached high frequency due to different founding populations and different drift paths. In Eastern Europe, the strong influence of steppe ancestry mixed with local hunter-gatherer and farmer genes created a different balance again. Lighter hair and eyes became quite common. Blonde and light brown shades are frequent across the Baltic and Slavic regions, but the particular cluster of MSI1R variants that produce the classic northwestern European red head never reached the same frequencies, not because they couldn't, but because of history's dice rolls, who migrated where, who survived, who had children. Modern genetic studies let us see this map in astonishing detail. When researchers sample DNA from thousands of individuals across Europe and look specifically at the MSI1R gene, they find a patchwork. Certain loss-of-function variants, mutations that weaken MSI1R's ability to make dark human, are especially common in places like Ireland, Scotland, Wales, and parts of England. Some of these variants, like those often labeled R151C or R160W in scientific literature, reach frequencies there that are rarely seen elsewhere in the world. Move into Scandinavia, and the picture shifts. Red hair-associated MSI1R variants are present, but often at lower levels mixed with a high frequency of variants linked to blonde hair. Go south into France and northern Spain, and you still find MSI1R diversity, but red hair becomes more sporadic, an accent rather than a dominant note. Cross the Alps into Italy or head into Greece and the Balkans, and red hair becomes rarer still, usually appearing in individuals who carry a stronger dose of northern or Celtic ancestry somewhere in their family tree. In Eastern Europe, red hair exists, especially in areas where Northwest European or Scandinavian ancestry is mixed in over time. But again, it's scattered, not concentrated. The overall pattern looks like a heat map that glows brightest in the British Isles, northern France, and parts of western Germany, then fades as you move away. But the story does. Essence stop with prehistory. After the Bronze Age, Europe doesn't freeze in place. The genetic deck keeps getting reshuffled. Roman expansion pulls people from all over the empire into new regions. Legions recruited in Gaul serve in Britain. Soldiers from Iberia, the Balkans, even North Africa end up on the misty frontiers. Some marry local women. Some leave children who carry a mix of Mediterranean and northern genes. A red-haired child born in a Roman fort on Hreen's Wall might have had a Guish mother and a Syrian father. Hair color doesn't care about culture, it follows the genes. Later, as the Western Empire crumbles, new groups move in. Anglo-Saxon and related Germanic peoples settle in what is now England, bringing with them more northern European pigmentation variants. Some of them had light hair, some dark, and a few certainly carried MC1R alleles that when mixed with the existing British gene pool would increase the chances of red-haired descendants. Then come the Vikings from Norway and Denmark. Ships sail to the British Isles, Ireland, northern France, even deep into Russia. They raid, trade, and settle. Norsemen take local wives in Dublin, York, the Hebrides, Normandy. Scandinavian DNA, with its own mix of Litar variants and occasional MC1R mutations, spreads into the already diverse genetic fabric of the Isles. Some of those Viking lineages survive to the present day, their descendants still lighting up genetic maps of Britain and Ireland with characteristic signatures. Each of these historical movements doesn't erase the old patterns. It layers on top of them. Roman soldiers don't remove hunter-gatherer genes. Vikings don't overwrite Neolithic farmers and Bronze Age steppe ancestry. Instead, they add threads to the tapestry, creating subtle gradients and local quirks. A coastal Irish village with a lot of Norse ancestry might have a slightly different balance of red versus blonde hair than an inland community with older Celtic-like roots, even if both share the same island. Modern genome-wide studies confirm this complex layering. When scientists run principal component analyses of European DNA, they see clusters that roughly correspond to geography, but blurred and connected. Within those clusters, MC1R variants form their own micro-patterns, rising to high frequencies in some areas, dipping in others, sometimes reappearing along old migration route. You can almost trace the path of ancient farmers up the Danube, or follow the echo of seafaring Norse along Atlantic coasts, just by watching where certain hair color variants peak. None of this means that red hair belongs to one tribe, or that it proves Celtic, Viking, or any other single origin. The reality is more tangled, more interesting. Red hair is the visible outcome of many migrations, many chance events, many ancient survival pressures playing out over tens of thousands of years. It's a signal that your ancestors at some point lived far enough north, long enough, and in small enough communities for a handful of MC1R variants to rise from genetic whispers to something you can see in the mirror. When you look at a modern map showing the distribution of red hair across Europe, you're not just seeing color, you're seeing deep time. You're seeing Neolithic hunters walking the shores of a post-glacial sea, Anatolian farmers carving fields out of forest, steppe riders crossing rivers with their herds. You're seeing Roman roads, Anglo-Saxon halls, Viking long ships. You're seeing isolation and connection, drift and selection, loss and survival. All of that compressed into a single, the shade of hair. And the story doesn't end with hair alone. The same forces that shaped the redhead hotspots of Europe also sculpted the skin tones, freckles, and UV sensitivities that often travel with them. Traits that tell an even broader story about how our ancestors learned to live under northern skies. By now, it's tempting to think of red hair as just hair, a vivid pigment, a striking color, a quirk of the MC1R gene sitting quietly in your DNA. But evolution doesn't usually work in isolated beauty choices. It builds packages, linked traits, whole systems that rise and fall together. Red hair is one of those systems. If you could zoom in on the skin of a red-haired, fair-skinned, heavily freckled person, down past the surface, past the tiny hairs and pores, all the way to the pigment cells, you'd see the same story that shaped their ancestors in ancient Europe, written in miniature. It all starts with MC1R. On the surface, MC1R is the red hair gene, but that's like saying the sun is a source of daylight. Technically true, but missing the point. MC1R isn't just about hair. It's a switch that tells your pigment cells, your melanocytes, what kind of melanin to produce. There are E2 main versions of melanin in human skin and hair. Melanin, dark brown to black pigment, excellent at blocking UV radiation. Pheomelanin, reddish-yellow pigment, much less effective at UV protection, but responsible for warm tones in hair and skin. In most people, MC1R works like a well-tuned thermostat. When your skin senses UV light, signals tell MC1R to push melanocytes toward making more humanin. You tan, you produce a natural sun shield. In many redheads, that thermostat is broken, but broken in a very specific way. Variants in the MC1R genre make the receptor less responsive or unresponsive. The signal comes in more sunlight, more UV, time to defend, but the receptor doesn't flip fully into eumelanin mode. The system defaults to foam melanin. The result is not just red hair on the scalp, it's a whole phenotype. Pale skin that doesn't tan easily, a tendency to burn, and very often freckles. The hair is just the most visible flag. The freckles are the map. Imagine your skin as a landscape spread under the sun. Melanocytes are like tiny pigment factories scattered through that landscape. In someone with lots of eumelanin, those factories respond fairly evenly to UV. The tan appear, similar to a soft gradient. In many redheads and fair-skinned people with MC1R variants, the factories don't act in unison. Some respond more strongly, some less. The signal to produce pigment is irregular. Instead of a smooth wash of brown, you get little hot spots of melanin production. Those hot spots are freckles. This is why freckles cluster in sun-exposed areas: the face, shoulders, arms, the upper back. Each freckle is a tiny historical record of where sunlight has been most intense. Summer after summer, they appear, darken, and fade with the seasons. Just as ice sheets once advanced and retreated across the European landscape, the freckles are not separate from the fair skin. They're evidence of the same underlying system, a low baseline of pigment punctuated by local bursts of melanin where UV hits hardest, pale canvas, scattered brush strokes of defense. Biologically, this arrangement is strange if you grew up near the equator, at least from an evolutionary perspective. Why would natural selection favor a skin type that burns easily, soaks up UV like a sponge, and struggles to build a proper shield? To answer that, you have to turn down the sun. Picture an Ice Age Europe sky. Clouds, low sun angles, long winters where daylight is dim and brief. Even in summer, UV levels are far lower than in the tropics. Under those conditions, dark, heavily pigmented skin, brilliantly protective near the equator, can become a liability. Our bodies need ultraviolet light for something crucial, producing vitamin D. Without enough vitamin D, bones soften and deform. Immune systems falter. Pregnancies become more dangerous. In low UV environments, any genetic tweak that lets more UV into the skin, just enough, not too much, can be a survival advantage. MC1R variants that reduce humlane and boost via melanin do exactly that. They open the gate. Fair skin lets UV penetrate more deeply. Less pigment means less shielding, which in a place like Paleolithic Ireland or Bronze Age Scandinavia might not be a weakness at all. It might be the difference between weak bones and strong ones, between surviving winter and not. The freckles add nuance. They're like nature's compromise. Low pigment overall for efficient vitamin D production, with localized patches of extra melanin, where UV hits hardest to keep the most exposed cells from taking all the damage at once. But like every compromise in evolution, there is a price. In the modern world, with people of all ancestries living under artificial lights and flying between latitudes in a few hours, that ancient trade-off shows up in our medical charts. Fair-skinned, red-haired, heavily freckled individuals tend to face a significantly higher risk of skin cancer, especially in high UV environments. Melanoma, basal cell carcinoma, squamous cell carcinoma. All are more likely when the epidermis is thinly shielded. Melanin itself may contribute to oxidative stress under UV, damaging DNA even before a sunburn appears. The very same MC1R variants that once may have helped children in northern climates grow strong bones can, under modern sun exposure levels, become dangerous. Yet, even here, the story isn't simply one of vulnerability. In low UV regions, northern Europe, cloudy coastal zones, high latitudes, the ability to produce vitamin D efficiently can still matter, especially in times or places without fortified foods or supplements. For much of European history, rickets, bone deformities, and other vitamin D deficiency conditions were common in darker-skinned individuals living far from their ancestral equatorial home, but far less common in the very pale. The redhead phenotype is a reminder that adaptation is always local and always conditional. What hurts you in Australia today might have helped your great-great-great-grandmother in the Orkney Islands 2,000 years ago. But the MC1R story doesn't stop at skin. If you call up the body's internal logs, look beyond pigment production, you find something unexpected: pain. Hospitals and anesthesiologists began to notice a curious pattern. On average, natural redheads seem to respond differently to pain and painkillers. In some studies, they reported more sensitivity to certain types of pain, like cold or dental procedures, yet showed altered responses to opioids and local anesthetics. It's not fully understood, and research is ongoing, but MC1R isn't only expressed in skin cells. It shows up in parts of the brain and in tissues involved in pain pathways. Some studies suggest that people with inactive or altered MC1R variants may require higher doses of certain anesthetics, like disurine, to achieve the same level of unconsciousness during surgery. Others hint at complex, sometimes paradoxical patterns: increased sensitivity to some pain stimuli, decrease AST sensitivity to others. In other words, the redhead package may extend into the nervous system. Different pigment chemistry on the outside, slightly different chemical signaling on the inside. Not better, not worse, but distinct. Imagine your ancient redhead ancestor on a cold, windswept plain, pale skin drinking in what little UV slips through the clouds, freckles mapping the places the sun touches most, a nervous system tuned just a bit differently, perhaps more sensitive to some forms of environmental stress, more resistant to others. None of these traits, skin, hair, pain, sensitivity, make sense alone. They're part of a coordinated pattern sculpted by a particular set of conditions: latitude, diet, climate, social structure, and chance. And then there is perception. For most of human history, people didn't know anything about MC1R or melanin chemistry. They just saw surfaces: the lightness of the skin, the constellation of freckles, the flame of the hair. Those surfaces became symbols. In medieval Europe, pale skin was often associated with nobility, not because of genetics, but because staying indoors, away from the sun, was a privilege. Fairness suggested a life untouchable, by field labor. Freckles could complicate that image. In some times and places, spots were seen as blemishes, something to be hidden under powders and veils. In others, they were youth marks associated with childhood, summer, and vitality. Red hair, fair skin, and freckles together formed a kind of visual archetype. Sometimes it was romanticized. The ethereal Celtic maiden, the tragic hero, the outsider touched by some otherworldly spark. Sometimes it was demonized. Medieval accusations of witchcraft, early modern stereotypes painting red hair as a sign of temper, untrustworthiness, or wildness. Ancient writers were no more consistent. Roman authors could admire the striking looks of northern barbarians even as they mocked them. Later, in Victorian England, pale, freckled skin might be framed as delicate and refined, while in 20th century schoolyards it became a target for teasing. The same phenotype endlessly reinterpreted. Underneath those shifting cultural stories, the biology didn't change. Freckles remained clusters of melanin. Fair skin remained a UV sponge. MC1R continued to misheat its chemical signals in the same way it had for tens of thousands of years. What changed with as the meaning we attach to them? From an evolutionary perspective, it's helpful to step back from the judgment and see the whole package as a single integrated adaptation. MC1R variants tweak melanin production that changes hair color, skin tone, and freckling patterns. It also seems to ripple into pain pathways, hormonal signaling, and possibly even immune responses. In an Ice Age or early Holocene European setting with long winters, low-angle sun, diets sometimes poor in vitamin D, and social groups small enough that any visible trait became a quick badge of kinship and difference. This package would have mattered both biologically and socially. Biologically, by influencing how your body handled sunlight and stress. Socially, by making you immediately recognizable as one of us or one of them, a subtle marker of ancestry, region, or clan. When you see a red-headed, freckled face today on a crowded city street in a classroom in the mirror, you're seeing all those layers at once. The ancient climate of Europe, the rise of farming and grain-heavy diets that pushed vitamin D demands higher, the migrations of small founder populations that amplified certain MC1R variants in places like Ireland and Scotland. The whispers of pain receptors and anesthetic responses hidden beneath the skin. The centuries of myths, stereotypes, and love stories projected onto a color, a pattern, a look. None of these traits evolved as isolated quirks. They're chapters of one story. A story where a single gene nudged by clouds, latitude, and chance reshaped not just hair but skin, freckles, physiology, and even the way entire civilizations would imagine the people who carried those traits. And that story doesn't end in the past. The same MC1R variants, the same freckles, the same pale canvas that once signaled survival in dim northern winters now exist in a very different world. One with sunscreen, indoor jobs, airplanes, and artificial UV lamps. Modern medicine turns what was once a raw evolutionary trade-off into a manageable risk. Cultural perceptions shift again with freckles celebrated in fashion campaigns, one decade digitally airbrushed away the next. Yet the biology is still doing what it has always done, converting sunlight into chemistry, scattering pigment into tiny constellations across the skin, carrying forward an adaptation born under cold grey skies into a global fluorescent age. Red hair is the flare that catches the eye. Freckles and fair skin are the quiet background, the context, the proof that what you're looking at isn't just a color, but an entire evolutionary strategy, a full package forged in ancient Europe, still walking among us, still changing how we see each other and how we see ourselves. Picture this. The ice sheets are gone. The mammoths are gone. The Neanderthals are gone. The world that forged the first red hair has melted into history. But the genes didn't vanish with it. They kept traveling from campfire to campfire, from village to village, from one uncertain generation to the next. Now the scene shifts forward brutally fast by evolutionary standards. The stone tools disappear. Bronze flashes, then iron. Forests shrink. Cities appear, empires rise and fall, languages are born and die, gods are worshipped and forgotten. And through all of that, the MC1R variants that help create red hair and freckles quietly keep moving through human bloodlines. Tonight, when the sun sets somewhere over Ireland or Scotland or Brittany or Scandinavia, there will be people walking under that sky whose hair still burns copper in the last light of day. Living echoes of Ice Age Europe, checking their phones, paying their bills, scrolling through social media, while carrying genetic adaptations that first spread among hunters staring out across frozen steppe. So, where are those genes now? And what happens to them next? If you could look down on the whole world and see only redheads, it would look almost like a ghost map of ancient northwestern Europe. The densest glow would cluster over the British Isles, especially Ireland and Scotland. Pockets would flare in Wales, Cornwall, northern England. There'd be scattered but noticeable dots in Scandinavia, the Low Countries, northern France, parts of Germany. Smaller clusters in places that once lay along old Celtic or Viking routes, coastal Spain, northern Italy, Central Europe, even bits of Western Russia. Outside Europe, you'd see lights following history's migration trails, Canada's east coast, parts of the United States, especially Appalachia and the Pacific Northwest, patches in Australia and New Zealand, traces in Argentina, South Africa, scattered cities around the globe where people of European ancestry settled. But even in those hotspots, red hair is rare. In most of the world, LD, fewer than 1 or 2 people in a 100 are naturally red-haired. Even in Ireland or Scotland, where the percentages peak, redheads are still a minority. Maybe 10%, sometimes a bit more, depending on the region and definition. That rarity is part of what makes red hair feel so striking. A relic trait from a particular time and place scattered across a modern planet that barely resembles the landscapes it evolved in. And yet, over the last couple of decades, you might have heard people say that red hair is disappearing. Headlines claiming that redheads are going extinct, that the last natural redhead will be born in a few generations, that modern society or climate change or intermarriage is erasing this ancient phenotype from the human story. So, is that true? To answer that, you have to remember how red hair actually works. It isn't a simple on-off switch. There's no single red head gene that pops into existence or vanishes overnight. What we call red hair is usually the result of at least one of several variants in the MC1R gene, often in combination, plus other genes that influence pigmentation. Most of those MC1R variants are recessive. That means you usually need 2 copies, one from each parent, for the trait to fully express as classic bright red hair. If you have only 1 copy, you may not be visibly red-haired at all. You might be blonde, brown-haired, or have orange tones that only show in certain light. You might just have a tendency to freckle easily or burn more readily in the sun. So, when 2 people with red hair have children, they're very likely to have red-haired kids. But when a redhead has children with a non-red head, the kids might not be red at all. The trait looks like it disappears, but genetically it's only gone underground, hiding as a single MC1R variant in people with otherwise normal hair. This is where the extinction myth breaks down. For a trait controlled by recessive variants to truly vanish from a large, stable population, the genes themselves have to be weeded out. That requires systematic intense selection against carriers, people who may not show the trait at all. There's no evidence that this is happening to MC1R in modern human populations. If anything, the opposite is true. In many parts of the world, populations with European ancestry, including those with relatively high frequencies of MC1R variants, have grown and pread more than at any time in history. Global travel and migration blend genes, but they don't delete them. Each new child born with one copy of a red hair variant becomes a carrier, a potential link in a chain that might in some future generation recombine with another carrier and produce another red head. When geneticists build models of how these traits spread, they don't see red hair disappearing. What they see is something more subtle. The visible clustering of red hair might become more diffuse over time as people move and intermarry across continents. The pockets of very high frequency, like rural areas of Scotland or Western Ireland, could slowly soften as new genes flow in. But at the same time, MC1R variants spread into places where they were once almost unknown. Instead of vanishing, red hair becomes more globally dispersed, less tied to one narrow region, less predictable. A possibility that can show up in a child in South Paulo or Sydney or Tokyo with a European grandparent as easily as in the Scottish Highlands. In other words, the trait isn't dying, it's democratizing. So, why do we keep hearing it's going extinct? Some of it is misunderstanding. Some of it is media exaggeration of old misinterpreted studies. Some of it might be an emotional reaction to seeing traditional local communities change. When you live in a small town that used to be mostly fair-skinned and freckled, and over a few generations you see more variation, it's easy to feel like something ancient is slipping away. But genes don't experience nostalgia. They simply move, recombine, and express when the conditions line up. As long as people carrying MC1R variants keep having children, red hair remains part of humanity's genetic library. While the science quietly undermines the extinction myth, culture has been busy doing something very different with red hair. For much of recorded history, redheads have been singled out, sometimes admired, sometimes feared, sometimes mocked. In different eras, they've been associated with fiery tempers, witchcraft, sensuality, treachery, luck, misfortune, often all at once. A walking canvas onto which societies projected their anxieties and fantasies. But in the last few decades, something new has emerged. Red hair as a conscious identity, a source of pride, community, and playful solidarity. All over the world, festivals have appeared that would have been almost unimaginable to Neolithic farmers or Roman census takers. Whole gatherings of people whose only qualification is that their hair, naturally or by heritage, glow somewhere between copper and flame. In the Netherlands, there's Rudari Gendag, Redhead Day, where thousands of redhead people and their families converge for photos, art, music, and a quiet celebration of being statistically unusual in a world of browns and blacks. In Ireland and Scotland, smaller local festivals echo the same idea. Picnic blankets scattered with freckled faces, children running around whose hair seems to catch the sunlight more intensely than the grass around them. These aren't survival strategies. They're something our Ice Age ancestors could never have imagined, being rare and safe, being different, and choosing to gather simply to enjoy that difference. At the same time, media representation has shifted. Where older stories often cast redheads as villains, seductresses, or comic relief, more recent decades have given us red-haired heroes, protagonists, complex main characters, animated films, fantasy epics, children's books, video games. They've all added to the slow remodeling of cultural expectations. A child with red hair today grows up in a world saturated with images where some of the faces that look like theirs belong to wizards, warriors, explorers, scientists, and ordinary people just living their lives. They still may face teasing. Prejudice and stereotypes don't vanish overnight, but the symbolic weight is changing. Being red-haired is no longer just something that happens to you. It can become part of how you choose to see yourself. And under all those surface changes, the deeper story remains the same. Every shade of human hair, from raven black to golden blonde to deep, or is a negotiation with the sun, a conversation between DNA and climate and chance. Red hair simply carries that negotiation to an ancient particular conclusion. Maximize vitamin D production in low UV environments, even if it means burning more easily when the sun is strong. When you look at a red head, you're not just seeing a color, you're seeing a fossil of adaptation, a visible trace of how seriously nature took the difference between southern and northern skies, of how many winters had to be survived, how many cloudy days endured before those MC1R variants were favored enough to spread. You're also seeing the aftermath of a much older story, the bottleneck, the Ice Age expansions, the movements of hunter-gatherers across cold grasslands where the sun stayed low for months on end. Because those MC1R variants don't exist in isolation. They ride on chromosomes that pass through Neanderthal-haunted valleys, over glacial marines, along coasts where Denisovan genes still echo in nearby populations. They're threaded through genomes that all trace back eventually to that small band of survivors in Africa 900,000 years ago who endured a climate horror far beyond anything we've yet experienced. Modern red hair is one tiny expression of that survival, one way that the ancient human toolkit for enduring hostile environments has chosen to reveal itself. In a crowded subway, a classroom, a cafe, a single head of red hair can stand out like a spark. Easy to notice, easy to remember. But genetically, that person is not separate from the rest of us. They're a variant, not an alien. Their MC1R changes sit alongside the same fused chromosome that marks all humans as children of the bottleneck. The same brain-building genes, the same language circuits, the same fundamental blueprint. If anything, red hair reminds us of how much variety can exist within a shared design. How a few changes in a single gene can create something visually dramatic while leaving our common humanity untouched. So, when people worry that red hair is dying out, they're touching something deeper than just pigmentation. They're reacting to the idea that rare traits can vanish, that particular stories of adaptation can end, that the colorful local textures of human variation might be smoothed away into something blander and more uniform. The science for now suggests that isn't happening. Red hair isn't going quietly into the dark. It's just moving, mixing, waiting for the right combinations of alleles to line up again, as they have countless times since the first hunter with copper hair walked across a snow-dusted plain. And maybe that's the most magical thing about it. Somewhere tonight, a child with no red-haired parents will be born with hair the color of drying embers, a surprise, a recessive inheritance resurfacing after generations of sleep. Their grandparents will pull out old photographs trying to remember who else in the family looked like this: an aunt, a great-grandmother, a face forgotten in a sepia portrait. They won't know it, but what they're really seeing is Ice Age Europe blinking awake in the 21st century. A climatic gamble from tens of thousands of years ago, paying out again in a hospital room lit by modern LEDs. That's the legacy red hair carries into the future. Not extinction, but persistence. Not a dying flame, but a slow wandering fire flaring up here and there, wherever the genes find each other again. Every redhead you pass on the street is living proof that the past never entirely lets go. That natural selections, experiments can outlast glaciers, megapora, and entire human species. That somewhere inside our very ordinary modern lives, there are still embers from a world of ice and mammoths and long, dark winters, a world, LD, in which a flash of copper hair in the pale northern sun might have meant one thing above all: survival. So now, as we come to the end of this journey, you can trace a single shimmering thread through everything we've talked about. From tiny bands of humans riding out Ice Age storms, to wandering hunters following herds across frozen plains, to farmers carving fields out of misty Atlantic hills, all the way to you, listening to this somewhere in the dark. That little thread is made of molecules, of course, of genes, of switches in your DNA that decide how much pigment goes into your hair, how your skin freckle sprays in the sun, how your eyes catch the light. But it's also made of stories, of migrations and meetings, of people crossing mountain passes and narrow seas, carrying their children, their tools, and their secret instructions for building red hair. The MC1R gene is just one of those instructions, a tiny stretch of code that under the right conditions softens the usual dark pigment and lets copper, amber, and gold come through. It didn't appear in a single person, under a single tree with a dramatic drum roll. It spread slowly, trickling through scattered families over tens of thousands of years, selected again and again by pale northern skies and weak winter sunlight and the quiet arithmetic of survival. Every freckle, every flame-cold curl is a reminder of that long calculation. When you picture a red-haired person now, it's easy to jump straight to modern images. Celtic warriors, medieval kings, maybe a neighbor, a friend, or the face you see in the mirror. But behind those familiar impressions stand older figures we'll never meet. Hunter-gatherers watching the aurora ripple over ice-age tundra, Neolithic farmers in the chilly rain of early Europe, Bronze Age traders peeling misty coasts, their skin pale from long winters, their hair catching stray beams of low northern sun. We can't see their faces clearly, the details are blurred by time, but the genetics tells us enough to know that some of them scattered through those forgotten populations would have carried the same variants that light up modern hair in copper and gold, the same variants that dust skin with freckles, the same variants that turned out to be useful under grey skies where every photon of sunlight mattered. So, when you think about red hair, you're not just thinking about a rare color or on a modern map. You're looking at a living fossil of climate pressure, migration routes, and ancient chants, a quiet signature of who lingered in the north, who thrived there, who passed on their genes when others did not. And that, in the end, is part of the wider beauty of human diversity. Every shade of hair and skin, every pattern of freckles or absence of freckles is a different solution that our species found to the same problem. How to stay alive in a world that never stopped changing. Dark hair, light hair, red hair. None of them is better in any timeless sense. They're just different answers written in different climates, at different moments, in deep time. Tonight, you happen to be listening to the chapter written in copper ink. As you drift towards sleep, you might let your mind wander back through that timeline, from the cool coasts of Ireland and Scotland, through Roman streets and steppe camps, back across Europe, back into Ice Age refuges, and further still into the deep past where these genetic pathways first began to diverge. Behind every statistic and every map is a chain of real people breathing, walking, laughing, staring up at the same sky. You know, their world is gone, but their hair color, their freckles, their hidden genetic experiments are still here, still glowing faintly in the present. The fire never really went out. It just moved into new bodies, new families, new stories. If you enjoyed drifting through this history with me and it helped you relax or expanded your sense of where you come from, you're very welcome to gently support the channel. You can tap, like if you'd like more people to find this while they are trying to fall asleep. You can subscribe and turn on notifications so you don't miss future journeys into the past. If you feel awake enough, I'd love to hear from you in the comments. Tell me where you're listening from, which country, which city, maybe even which landscape surrounds you. Are you in a northern latitude, under the same kind of skies that once favored red hair, or someplace very different, far from those ancient European climates?